All right, 2 left. Number 9, so this is where we're going to graph these types of patterns that we've been working with, these exponential patterns. If you think back to that very first problem where we were talking about Eddie doing his push-ups, he started off with a really small number, and then it took off really fast. So it wasn't something that was linear. It was something that kind of had like that kind of shape to it, where it started off small and then really took off. Well, so that's what we're going to be kind of looking for in this. Anytime you need to graph something, you can always just pick some x's, plug it in, and plot the points that come out. So that's going to be the approach that we're going to take. We just looked at negative exponents in that last problem, but let's just start with the positive exponents. So let's say, for instance, that if I took, and I'm just plugging in, and there's not maybe a whole lot of room on your paper for this, so there's 2 ways you could do this. You could just plug it in by doing, let's say this is our x. So we're plugging in 2, right? Because that's going to be our x. Well, 2 squared is 4, right? 2 times 2 is 4. 4 times 4 would give me 16. Right, so that would be 16. And then what that means is that the point would be, my x is 2, my y is 16, so I would have a point right there. The alternative, I could have just put that into the calculator as well. I could have said 4 times 2 raised the roof to a positive 2, and I get the same thing. I get 16. And I could do the same thing for each one of them. Let's say if I looked at 1, right? So 2 raised the roof 1, which I get 8. So I'd have an 8 right there. So what that means is that x go right 1, go up 8. The proof of how if I did that by hand is if I plug in 1, I'm plugging it into the same thing here. It's just this time instead of doing a 2, I'm going to do it to the first power. And you could also do, I picked numbers that were hopefully kind of simple enough that we could do a little mental math with. 2 to the first power just would be 2, and then 2 times 4, which would give you 8. Right? We've already kind of proven with 0 that anything to 0 power is equal to 1. So let's see what that would look like. Is that if we put that in with our table, we'll do the calculator second. Let's go table first. So if I plugged in 0, I've got 4 to the 2, and this time not 2, not 1, but 0 equal to 8. Well, 2, we said that anything to the 0 power is just equal to 1, and then so 1 times 4, I'm not sure why I wrote 8 right there. 1 times 4 would give you 4. I could put that in right there. So I'd have 0 and then 4. If I wanted to prove that on the calculator, I just would do 4 times 2, raise the roof to the 0, and I get 4. All right, so everything's checking out. And you see how this isn't a line. You see how this is kind of starting to really take off fast, and then what we're doing is we're thinking the other points are going to be down here somewhere. So let's say with this negative 1. So I've got 4 times 2, raise the roof to a negative 1. And I get 2. All right, so I get 2. So what we're saying is that we've got negative 1, go up 2. So I've got a point right there. Proof of it using the table. So if I did negative 1, I got y equals 4 times 2 to the negative 1. Now we said that 2 to the negative 1, maybe kind of do a little scratch work here, right? Or actually we can go back to the last one we looked at. We said that 2 to the negative 1, this right here, is equal to 1/2, right? Because 2 to the positive 1 is 2. So if you flip that, you get 1 over 2. And then, so what this is saying is that, well, 1/2 of 4, what's half of 4? Well, half of 4 would be equal to 2. And last but not least, let's plug in a negative 2. So we've got 4, and then negative 2, I'm sorry, positive 2, raised to the negative 2. And then so we get 1. So we get and I think did we graph our last point there? Yeah, we got negative 1, 2, and then now we've got negative 2 and 1. So we've got something that looks like that. And if we kind of used our imagination, we could imagine that what happens is that this gets infinitely close to 0, but actually doesn't touch 0. So it kind of rides barely along there, and then what happens is it then starts to take off, right? And so that's what we'd define as something exponential, right? So this is an exponential curve. Right, and go back. Why? Go back to what you said on number 1, because the rate of change wasn't constant, right? So the rate of change, if you see how this is changing, that goes up 1, that goes up 2, that goes up 4, and it really starts to jump. Goes up 8, right? What do you think it'd go up next by? Well, it'd go up by 16. So it'd just start getting steeper and then steeper. Right? All right. So go ahead and pause. Now stop the video and try number 9 on the right side.